In this video, I'm going to talk about the common logarithm. So yeah, there's a logarithm that is so common that people started calling it the common logarithm. And that logarithm is the base 10 logarithm. It has a base of 10. So like this. You could write it like this, log base 10. And yeah, I mean, this is really, really important. It's used so much in the world. So, pH, like measuring how acidic things are or measuring how basic things are, that involves the common logarithm. Or decibels, like for example, measuring how loud things are, that also involves the common logarithm. Those are just two applications of the common logarithm. It's very, very important. Okay, here's an example of a common logarithm that maybe you would have to do in a math class. What is the common logarithm of 1,000? Like, what is log base 10 of 1,000? Well, the way you do this logarithm is the same way you do any logarithm, right? If you remember from the previous video, there are two ways that you can think about logarithms. So here's the first way. How many tens do I have to multiply to get 1,000? How many tens do I have to multiply to get 1,000? Well, let's see. 10 times 10, that's 100. So not quite 1,000. Okay, well, let's multiply by another 10. Now we have 1,000, right? Okay, we got the number we're looking for. How many tens do we have to multiply? 1, 2, 3. So the answer is 3. Here's a second way you can think about logarithms. 10 to what power is 1,000? 10 to what power is 1,000? Let's see. 10 to the power of 2, like 10 squared, that would be 100, so not 1,000. What about 10 to the power of 3, so 10 cubed? That would be 3 zeros. That would be 1,000. Okay, we got what we're looking for. What was the power we had to use? 3, right? So the answer is 3. Those are the two ways of thinking about logarithms, and those two ways work here. So yeah, by the way, the second way is the better way of thinking about this. It's just a superior way of thinking about logarithms in general, because it will work when you have to do even like advanced logarithms. Like you can even have logarithms that involve like fractions and stuff, and this way of thinking will really work well when you're doing logarithms that involve fractions and other more complicated things. Okay, so one last thing I must mention. I would be remiss if I did not mention this. There is another way of writing the common logarithm. People were like, we're writing this logarithm so much, we should come up with a simpler way of writing it. Okay, here's a simpler way. There it is. What happened to the base? It disappeared, right? Yeah. So it basically, if you see a logarithm that doesn't have a base written, it's probably the common logarithm, right? Like the base of 10 is assumed. You're supposed to assume that the base is 10. I mean, it's the same exact idea as like, I don't know, a square root, for example, right? People don't write the 2 up here normally, right? People don't write that 2 because you're supposed to assume, right? You're supposed to assume that it's a square root, even though the 2 isn't up there. Same exact idea, right? It's the same exact idea. You're supposed to assume that there's a 10 down here. You're supposed to assume that the base is 10, even though it's not written. So what would the answer to this logarithm be? Well, it would be 3, right? Because it's the same as the answer here. These are the same logarithms, right? They're the same logarithm, so of course they have the same answer, right? These are just different ways of writing the same thing. Thanks for watching.